You want to build awesome games and master front-end web development at the same time? In this vanilla JavaScript and HTML5 canvas game tutorial, I want to show you 5 techniques I wish I used sooner. Today we will build a game completely from scratch, step by step, with no frameworks and no libraries. We will learn how to achieve pixel-perfect collision detection using colors, how to use timestamps and delta time to make sure our game runs at the same speed on different machines. We will learn about arrays, and I will show you how to remove all the game objects using array filter method, and how to use array sort method to create a correct draw order in a 2D game. We will also talk about modern JavaScript syntax, and we will learn how to make our animation code cleaner and less repetitive with Sprite operator. I will also share many small tips and tricks as we go along. Students of today's course will get 2 premium Sprite sheets completely for free, kindly provided by this amazing artist. Check out his website for more. Click the like please if you are excited and ready to learn. Let's talk about JavaScript. Have fun! I want you to build projects you can show off to someone and be proud about. So as usual, we will build a game, and by the end of this tutorial, you will have a complete project. I learned some of these techniques from my friend Radu. He has a lot of other cool things to teach you. If you want, you can go and check out his courses. I will link some in the video description. Some of you tell me that you only make games by animating divs and other HTML elements. It's a great way to start and learn the basics. HTML canvas can handle many more moving objects at the same time. So if you want to try and build games that have a little bit more complexity, maybe this is the time for you to give Canvas a chance. Let me show you it is easier than you think to build interactive animated projects with it. I will take you through it step by step and help you understand. I have an introductory game development series and a beginner playlist where I go slower over all the important techniques. If you find yourself struggling at some point, or you think I'm going a bit too fast, maybe try to watch that one first. Over there we also create really cool projects, but I keep beginners in mind at all times. It might be an easier starting point for you, and then you will be ready to take on videos like this one and actually properly understand everything. I will leave some links in the video description. Let's go! Let's create some ravens. I will have an array that will hold all my raven objects. It needs to be a let variable, not const. I will explain why in a minute. I create a custom class called Raven. It will be a blueprint based on which all my animated ravens will be created by JavaScript. Constructor will create one blank new object every time it is called, and it will assign it properties and values as we define them here. It will have width property, and its value will be, for example, 100 pixels. Height will be 50 pixels. This.x starting horizontal x coordinate will be just behind the right edge of canvas, so they can fly across to the left, so canvas width. Vertical y coordinate will be a random number between 0 and canvas height. Since rectangles on canvas are drawn from the top left corner, going right and down, I don't want any ravens to be partially hidden below the bottom edge of screen. Initial y position will be a random number between 0 and canvas height minus the height of a raven. Between here and somewhere around here. It needs to be in brackets like this to give us the correct range of values. Direction x will be horizontal speed basically. It will be a random number between 3 and 8. I want ravens to bounce up and down as they fly. So the initial vertical speed, I call direction y for example, will be a random number between minus 2.5 and plus 2.5. Minus values will move upwards, plus values will move the raven down along the vertical y-axis. Update method will move the raven around and adjust any values that need to be adjusted before we draw the next frame. At first I will just simply move it to the left, so this.x from line 11 minus equals this direction x from line 13. Draw method will take these updated values, and any drawing code we put here will represent single raven object visually. First, let's start with a simple rectangle. I call built-in fill rectangle method, and I pass it x, y, width and height. Raven class is complete. We have a way to create ravens. Let's create animation loop. I create a custom function I call, for example, animate. It will take argument I call timestamp. This will be a numeric value in milliseconds, so 1 second will be number 1000. I will show you exactly how it works. Any code inside this animate function will run over and over, updating and drawing our game frame by frame. The first thing we will do between every frame is clear old paint, old drawings from the previous frame. So clear rectangle, and I want to clear the entire canvas from coordinates 0, 0 to coordinates canvas width, canvas height. We will run some code in between, and then at the end we will use requestAnimationFrame method that will call animate again, create an endless animation loop. I will console log test to make sure it works. And I also need to call animate like this on the first page load to trigger the first loop. In browser console I can see the loop is running, perfect. It's good to test your code as you go to make sure there are no typos. It's safer than to write the entire project and then try to look for bugs there. Step-by-step approach will save you a lot of time. I can also test if my Raven class is working. I will use it to create many Ravens, but I can also just create one. I create a variable called Raven and I assign it to new Raven like this. This will create one Raven object for me, which will have access to update class method from line 16 and draw method from line 19. I call it from inside my animation loop, and here's my Raven. It just flies over once. If I refresh the page, it flies again. This works. So far we are doing great. Instead of having one Raven, I want to create a new Raven periodically, and I want to make sure that periodic event is triggered at the same interval on very slow old computers and on brand new gaming super PCs. To make sure the timings in my game are consistent and based on time in milliseconds rather than on the power of my computer and its ability to serve frames at a certain speed, I will use timestamps. I will compare how many milliseconds elapsed since the last loop, and only when we reach certain amount of time between frames, only then we will draw the next frame. It's actually very simple, but it might take some time to get used to it if you are a beginner. Let's do it and see how it works. What is happening here, we are calling animate using requestAnimationFrame. Animate becomes a callback function on requestAnimationFrame method, and default JavaScript behavior for callback here is to pass it automatic timestamp as an argument. Its value is in milliseconds. Just so you know where this timestamp will be coming from, it's a default JavaScript behavior when using requestAnimationFrame. It will pass its callback function, in our case animate, automatic timestamp argument. We will see it better in a minute. As the loop runs, requestAnimationFrame calls animate over and over, passing it timestamps. My goal here is to take time from the current loop, save that value, run the loop again with a new timestamp value, and compare them to see how many milliseconds it took in between frames. I will need some helper variables here. Time to next Raven will be a variable that will accumulate millisecond values between frames until it reaches my interval value and trigger next frame. Initially, it will start at 0. Raven interval will be a value in milliseconds. Every time to next Raven accumulates enough to reach 500 milliseconds, it will trigger next Raven and it will reset back to 0 to start counting again. I will also need a variable that will hold value of timestamp from the previous loop. The initial value will be 0. Inside my animation loop, I will calculate delta time. This will be a value in milliseconds between timestamp from this loop and saved timestamp value from the previous loop. After I used last time value to calculate delta time, I will assign last time variable from line 8 to the new timestamp passed here in this loop, so that we have that value ready to compare in the next loop. Let's console log timestamp. I can see I misspelled last time here. Capitalization of letters is very important in JavaScript. You can see in console I'm getting timestamps in milliseconds since the loop started. The very first value is a second, so it goes like this: 7, 8 seconds and so on. So this is the automatically passed timestamp value here. It's generated by default by JavaScript because we made animate into a callback function on requestAnimationFrame method here on line 33. There is a way to do this without calculating delta time at all, but I haven't tested that and I'm not sure what is the browser support for that technique, so let's go with this tested safer solution today. I will remove console log. Leaving too many console logs in your projects, especially the ones running so often like this, can affect your performance, so keep that in mind. On line 6 I have time to next Raven variable. Here in my animation loop I will increase its value by delta time for every animation frame. I will console log delta time now. Again, I need to be careful about spelling my variables correctly here. I can see that on my computer, time between frames is around 16 milliseconds. My computer is powerful and it is able to serve a new frame every 16 milliseconds. On your computer, the number might be different. I would actually be very interested to know if it's the same number or a different one for most of you. If you are following and coding with me, can you leave a quick comment with that number, please? You can just type 16 if it's the same number or whatever different number you are getting right now. So time to next raven starts at 0 and is increasing by this value of around 16 milliseconds per each frame. On line 7, I created a variable called raven interval and I set it to 500 milliseconds. In my animation loop, I will say when time to next raven reaches this raven interval, when this number that starts at 0 and increases by the amount of milliseconds that happened between frames reaches 500, at that point we will take raven's array from line 10 and use built-in array push method. I will pass it new raven, which will trigger my raven class constructor. Create one new raven object and it will push it inside raven's array. When that happens, I set time to next raven back to 0 so it can start counting again from the beginning. I know I just said raven a lot. Time to next raven starts at 0, it increases by the amount of delta time, by the amount of milliseconds between each frame, which will be dependent on performance of your computer. However, since slower computers will take longer to serve the next frame, their delta time will be a higher number and it will move towards our target raven interval in bigger steps. As a result, this code will be triggered at the exactly same time on slow and fast computers. This is one way how you can properly trigger periodic events in your projects using timestamps. This might be a bit too much to wrap your head around if you are a beginner. It's one of the reasons I don't always use timestamps in my animation tutorials, because I can't really explain all of this in every single video, but try to learn it if you can. If you still don't get it, don't worry. I will explain it in future projects again, so eventually it will start making more sense. Repetition and practice is the best way to learn, at least for me it is. I console log ravens and I see nothing is happening, even though my animation loop is running. It seems that this if statement never evaluates the true, so the code inside is never triggered. Console log is great for debugging. I console log time to next raven first. Oh, I can see its value is a none, not a number. Here's our problem. Why is it this value? It must be because we are adding delta time to it here. I console log delta time and I can see that the first initial value is also not a number. Delta time is calculated here on line 30, so now I console log timestamp. And this is the root of our problem, that cascaded all the way through my variables that use each other to calculate their values. When the animate loop starts, the very first timestamp is undefined because timestamp only gets created on the second loop here on line 39 when we call request animation frame. To fix that is easy. I just need to give timestamp a starting value on the first call of animate that starts my animation loop here. I will pass it timestamp of 0 as an argument. Awesome, that fixed it. And since I'm console logging raven's array on line 36, I can see it adds new raven object to the array every 500 milliseconds. I remove the console log. We have data for ravens inside the array. We just need to cycle through that array through every single raven object and call their update and draw methods so that we can actually see movement on canvas. I declared my ravens array here on line 10. Inside animation loop, I will use this syntax, which might be a bit unusual for you. Here I'm creating so-called array literal by just dropping square brackets like that. I'm creating a quick new array on the fly, and these 3 dots are so-called spread operator. Now I'm spreading my ravens array inside this new quick array I just created. Spread operator allows us to spread iterable, such as this ravens array, to be expanded into another array. Let's finish writing this line of code and I will explain why I'm doing that. Since we are dealing with an array, I can call built-in array for each method. I need to assign it a variable name for each object in this array, so we can use it as we iterate. as we cycle through it. I will call that variable, for example, object. So this object variable now represents each individual Raven object in Raven's array. And I can say for each Raven object in Raven's array, call their associated update method we wrote on line 20. So this line of code will cycle through the entire Raven's array and it will trigger update method on all of them. Since we are inside animation loop, this will happen over and over for each animation frame. I will do exactly the same thing for draw method from line 23. And we are updating and drawing our Ravens. Awesome. Now you might ask, why am I using this fancy syntax here, where I created a new array and I used the spread operator to expand my Ravens into that new array, just so that I can call update and draw on them. I could have just called it on the Ravens array directly without expanding it like this. The reason I did that is because when I create particle class in a minute, I can just spread my particles into the same array along with the Ravens. As long as my particle class will have update and draw methods to call, the code will work and I can call all my classes by just expanding more and more arrays in here. I can, for example, also have an array of enemies, obstacles, power-ups and other elements in my game. I can spread all of them into a single array and call their update and draw methods all at once. I will show you exactly what that looks like in a minute. I think it makes the code look clean and easy to read. What do you think? On line 34, I'm periodically adding new object into Raven's array. Right now it's an endlessly growing array of objects, and on lines 37 and 38, I'm iterating over all of them, even the ones that have moved off screen and are not visible anymore. Eventually this would build up and cause performance issues, so I need a way to remove the ones that have moved past the left edge of game area. Sometimes I use array splice method to do that. I used splice in many other tutorials before, but there might be a better way to do it. Using splice while cycling through the array removes objects from somewhere in the middle of the array, so then we have to write code to adjust the index to make sure neighbors of that object don't get skipped. Easier way to discard objects we don't need might be using built-in array filter method. We will just run through the array, call update and draw for each Raven, and then we will filter out Ravens that have moved past the left edge of screen. What does that look like in JavaScript? Let me show you. I create a new class property called marked for deletion, and initially I set it to false. In update method, I say if horizontal x coordinate of this particular Raven object is less than 0 minus this.width, meaning it has moved all the way behind the left edge, I set its marked for deletion property to true. Inside animation loop, I take the variable that holds my Ravens array from line 10 and I reassign it to a new array. That's why the initial declaration of Ravens array needs to be a let variable, not const, because const variable cannot be reassigned. It will be the same array, but objects that have marked for deletion property set to true will be filtered out. Filter method creates a new array with all elements that passed the test implemented by provided function. So here I'm saying take Ravens variable from line 10 and replace it with the same array, but I want that array to be filled only with objects for which this condition is true. Here we have a little bit of double negative, sorry. The test in my callback function wants marked for deletion value to be false. If marked for deletion is false, then this condition evaluates as true and this particular Raven object will not be deleted. Again, and said very simply, take Raven's array from line 10, delete everything in there and replace it with contents of the same Raven's array, but only with those objects that have marked for deletion property set to false. Exclamation mark here means false. Since we are console logging Raven's array on line 42, I can check in browser console and I can see that number of objects in the array is between 3 and 6. It only contains Ravens that are active and visible on screen. Perfect. I remove the console log. These Ravens look a bit boring, just black rectangles. Let's use animated sprite sheets instead. On my class, I create a new property called this.image and I set it equal to new image. I set source on that new image as Raven PNG. Art for this episode was made by this amazing artist. Link to his website is in the video description. He also allowed me to share this particular sprite sheet completely for free with my students, so you can download it along with all other project files in the description. For more game art, check out his website and support him if you can. There aren't many good 2D artists like this, and he's one of my favorites. I try to buy his game art assets whenever I can. I will need a couple of helper properties here. This.SpriteWidth is width of a single frame in my Ravens sprite sheet. In this case, 271 pixels. If you are using a different sprite sheet, take its width and divide it by the number of horizontal frames. Maybe it would be easier if you follow along with me using the same sprite sheet, and then when you understand the code and it's working for you, you can replace it. Sprite height is 194 pixels. On line 31, inside draw method, I call built-in draw image method. It expects between 3 and 9 arguments, depending on how much control you want over the image you are drawing. Minimum is 3 arguments, image you want to draw, so this.image from line 20, and x and y coordinates where to draw it. Now it's just simply taking the entire sprite sheet and drawing the whole thing at its original size. We can also give it optional width and height arguments, which will scale it. I need to make sure my brackets and commas are correct here. So now it's scaling the entire sprite sheet to fit inside 100 times 50 pixels. Let's do stroke rectangle here so we can see it better. We can also give it a total of 9 arguments. These additional 4 arguments will allow us to only crop portion of the image: source X, source Y, source width and source height. So the longest version of drawImage method takes 9 arguments: image we want to draw, x, y width and height of area to crop out from the source image, x, y width and height of where to place that cropped out image on destination canvas. Let's just crop out the first frame now. Source x and source y is coordinates 0, 0. Source width is sprite width and source height is sprite height. You can see our ravens are a bit stretched. It's because these initial width and height values are completely disconnected from the actual dimensions and aspect ratio of our sprite sheet. I moved sprite width and sprite height up here so that we can use them to calculate values that come after. Width could be, for example, sprite width divided by 2, and height could be height divided by 2. This works, but now all our ravens are the same size, and as my friend Marcus says, multiplication is faster than division, so let's create a new property called size modifier, and it will be a random number between 0.4 and 1. Now, instead of dividing it by 2, I will multiply width and height by this random size modifier value, which will make the ravens be different sizes, while still preserving the aspect ratio, so no stretching. This.frame is the number of frames in our sprite sheet counting from 0, so the initial value will be 0, this frame. This.maxFrame could be 4 or 5, depending on how you reset it back to frame 0. Let's go with 4 maybe. I will adjust my frame reset check to this value in a minute. If this.frame from line 25 is more than this.maxFrame from line 26, set this.frame to 0. Else, increase frame by 1. To actually reflect this value on canvas, I replace sourceX argument on line 37 with this.frame times this.SpriteWidth. So it will go 0, 1, 2, 3, 4, 5, and back to 0. As frame variable cycles on line 32. All the ravens are flapping wings very fast and at the same interval. How do we speed up or slow down sprite animation, the speed at which the next frame is served, and how do we make sure it's consistent across all machines on old, slow computers and new powerful ones as well? We can do that by using delta time. We calculated delta time on line 43 inside animation loop. Delta time is the difference in milliseconds between last frame and current frame, and this value will differ based on power of your computer. Some computers can serve frames much faster than others. Since I already calculated this speed at which my machine can serve frames in my game, I will just pass delta time as an argument to my update method here on line 50. That way it will be available up here. Let's test it. I console log delta time. It won't be available until I pass delta time as an argument here as well. Now the values are coming through. I will need a couple of helper properties. Time since flap will be 0 at first. It will be growing by the amount of delta time until it reaches value in flap interval. Then it will trigger next frame of sprite sheet and reset back to 0. This .time since flap plus equals the delta time. Remember that delta time is the amount of milliseconds between frames, so faster computers will have smaller numbers here, slower computers will have high delta time values. As a result, it will reach the target value at the same time on slow and fast computers, unifying animation speed across different devices. I say if this .time since flap from line 27 is more than flap interval from line 28, only then run this code that handles cycling through frames. For this to work, every time this condition is met and if statement is entered, I also have to reset time since flap back to 0 so it can start counting again when to serve the next frame. Now I can change the value of flap interval and you can see it changes the speed at which we cycle through frames in our sprite sheet. 500 milliseconds per frame is very slow. 5 milliseconds per frame is fast, faster than my computer can handle, since we know my computer can handle the serve next frame every 16 milliseconds as maximum. I can also randomize flap interval so that each raven animates at a slightly different rhythm. Random number between 100 and 200 feels too slow. How about a random number between 50 and 100? That feels better. Quick recap, we are calculating delta time, difference in milliseconds between last frame and current frame. The value of delta time will be different on slow and fast computers. To make sure we have consistent timing across different machines, we have time since flap variable that increases by the value of delta time per each frame until it reaches target value in the flap interval. Then it serves the next frame, resets back to 0, and starts counting again, preparing to serve the next frame. Ravens are flying in straight lines from right to left. I also created the direction Y property on line 21. It's a random number between -2.5 and +2.5, so some ravens will move up and some will move down in a negative or positive direction along vertical Y-axis based on this value. Inside update method I say this.y plus equals this.direction y. Now you can see some vertical movement. It's now a little bit harder to target them, making our game more difficult for players. One thing I don't like now is how they disappear behind the top and bottom edge. I want them to move all the way across the screen, and when they touch bottom or top edge of game area, I want them to kind of bounce and reverse their vertical movement to the opposite direction. I do that with an if statement. I say if this.y is less than 0, or if this.y is more than canvas height minus this.height. Set their direction property from line 21 to its opposite value, this.direction y times -1. Now they just bounce when they reach edges of the game area. Let's draw score. I create a let variable called score and I assign it to 0 initially. I create a custom function called drawScore. Inside I set fill style to white. I want white numbers. I call built-in fill text method. Inside I will hardcode string score :space plus score variable we just declared, and I want it drawn on canvas at coordinates 50, 75 for example. Now I just call drawScore from inside my animation loop. Keep in mind, since we are drawing everything on the same canvas, sequence in which you call this will affect how our game is layered. I want score to be behind ravens, so first I draw score, then I draw ravens. It's very small, so let's set the global canvas font to 50 pixels impact. Now it's easier to read. I will play with it a bit. I can use canvas shadows here, but I can also just draw the same text again at slightly different coordinates, for example 55 and 80. The first layer will be black, the second layer will be white. In the game, we will have to click ravens before they disappear behind the left edge of screen. I create an event listener for click event. Callback function on event listener has the default access to this event object. I assign it variable name, for example e. It contains information about the click event that happened. For example, its x and y coordinates in relation to viewport. If I console log e.x and e.y, I get coordinates of my click whenever I click somewhere in the game area. I promised we would do collision detection by color today. To do that, we first need to know what color is the pixel we are clicking on. I create a custom variable I call, for example, detect pixel color. It will be equal to built-in getImageData method. GetImageData simply scans area of canvas and returns an array-like object called uint8 clamped array. It's a simple data structure full of unassigned 8-bit integers. It's clamped, which means it can contain only integers, whole numbers between a certain value range, specifically between 0 and 255. Let's scan canvas and inspect what it gives us. GetImageData needs 4 arguments: x, y, width and height of area we want to scan. I want to scan just one pixel we click on with mouse, so coordinates of this click event e.x, e.y, and width and height of scanned area will be just 1 pixel. We want pixel perfect precision here. Okay, let's just console log this variable to see in what format getImageData gives us the pixel color, to make sure we understand how it works. If you are getting an error at this point, keep watching. I will explain it and I will show you how to deal with it. Now, whenever I click somewhere on canvas, getImageData scans area of 1 pixel directly under the mouse click, and it gives us this image data object. This auto-generated image data object contains 3 main properties. Data property, which is an array, currently it has 4 numbers inside, and width and height of scanned area, in our case 1 pixel. The way color data is structured here is that each 4 elements in this data array represent 1 pixel. Specifically, it's red, green, blue and alpha value. If you use CSS, you know that any color can be created by combining a certain amount of red, green and blue. The only difference between CSS RGBA declaration and this is that in CSS, opacity is a value between 0 and 1. Here, opacity, alpha, is also a number between 0 and 255. 0 is transparent, 255 is fully visible. Here, for example, you can see I clicked and it gave us 0, 0, 0 for red, green and blue and 0 for alpha. It means we clicked somewhere in the empty area. Keep in mind that canvas is just the ravens and score. The rest is transparent. Rainbow colors you see are on the background and are applied to body element with CSS. We are calling getImageData on CTX variable, so it is just scanning that particular canvas element. It doesn't see anything else. Some of you might be getting error when you click on canvas and try to run getImageData on it. We are drawing sprite sheets, our raven images, on canvas. In some browsers, you won't be able to call getImageData on the same canvas where you draw images. It will give you an error that says something like canvas was tainted by cross-origin data. If you are running your code locally, most likely you see that error. I'm using local server, so I'm not getting that error right now. It's a security measure related to cross-origin resource sharing. Apparently there could be viruses hidden in some images, and by scanning that image with getImageData, you could expose yourself to that virus. There are many ways to get around this problem and scan canvas without exposing yourself to any potential risks. In our case, it's simple. Let me show you. But first, I will assign a differently colored hitbox to each raven. So I want one canvas that has only these hitboxes and no ravens. Because when I click it, I want to get color of that particular hitbox, not of the black raven. If I create a secondary canvas and I use it just to draw these hitboxes and no images, it won't give me tainted canvas error. I will explain more as we write it. In index.html, I create an additional canvas with an ID of collision canvas. In style CSS, I comment out rainbow background for a moment so that it's very clear what we are doing. The same as I set up the first canvas, I will also set up this new collision canvas. Be careful here, I always make mistakes and typos when assigning multiple canvases like this for some reason. I don't know why. Constant variable called collision canvas is document getElementById collision canvas. collision CTX, which is context, is collision canvas.getContext2D. I also set collision canvas width and height. Just to check, I give it red background. Yes, it's covering the entire browser window, perfect. On my Raven class, I create a property called random colors. At the point where each Raven is created, I want to roll the dice and randomly give it red, green and blue color value. We know that color values can be in a range between 0 and 255, so red will be math.random times 255, like this. It will give us decimal points. I need only integers here, so I wrap it in math.floor. I do the same thing for green and blue. Now we have 3 random values in this array assigned to each Raven object. I create one additional property called this.color, and here I concatenate RGBA color declaration using these values. Red is random colors index 0, green is index 1, and blue is index 2, plus closing bracket like this. To use this color, I declare fill rectangle on line 54 and I set fill style to this.color from line 37. Now each Raven has a random red, green and blue color assigned when it's created by our class constructor, and we use these 3 values to create RGB color for its hitbox. Hitbox means collision detection area, and in our case, it's the colored rectangle around each Raven. We can also do much more complex shapes and still get pixel perfect collision detection, but for purposes of this tutorial, rectangles are fine. I don't want to complicate things too much. This tutorial is to help you understand the technique. So now each Raven has an array of 3 random values between 0 and 255, and these values are used to draw its hitbox. We will use these values kinda as a unique password for each Raven. We click on canvas, get RGB value of that pixel we clicked on using getImageData method, and we compare them with this random colors property. If they all match, we know we click on this particular Raven. This technique has one downside. There is a very small chance that there will be 2 identical colors generated next to each other, but since we do random number between 0 and 255 3 times, and we only have between 3 and 7 active Ravens on the screen at any given time, the chances of that happening are astronomically low. If we have any math experts who can run the numbers, let me know in the comments. It will be 1 in millions, possibly billions. Now I told you what I want to do. What does that look like in JavaScript? Before we write collision code, there is one small thing: layers. I want big Ravens to be up in front and small Ravens to be behind, to create a sense of depth and correct the draw order in a 2D space. Right now, sometimes you see smaller Ravens up front because they are drawn here on line 83 based on the order at which they were pushed into the array on line 78. I don't have to sort them for every animation frame, only every time I push new Raven to the array. I want to sort out all objects in the array by size. I use built-in array sort method. Sort method will simply reorganize order of elements in the array, their indexes, based on provided check in a callback function. It will run through the array and compare every element against every other element and sort them in ascending or descending order. Ascending order is default. It will run over my Ravens array and use these A and B variables for each object. I can choose many different properties to sort them by. Today I will choose width because I know Ravens in the back will have smaller width than the ones up front. I'm just going to return it like this, simple syntax, and I'm comparing width of every element in the array against the width of every other element in the same array. A minus B will sort my array in ascending order based on width, which is exactly what I want. I want small ones to be drawn first and larger ones to be drawn on top. You can read more about built-in JavaScript sort method online. We can see that it works. Large Ravens are up front and smaller ones are behind. Perfect. As I said, I want to avoid tainted canvas error, so I need to make sure I have a separate canvas I can scan color from that doesn't have any images drawn on it. I take collision context variable I declared on line 6 and I draw my colored rectangles on that canvas instead, by adjusting code here on lines 54 and 55. Nice, that worked. I can see we are not clearing the old paint on that canvas, so on line 74 I call clear rectangle on collision context as well. Now we have two canvas elements. One has colored collision rectangle and the other has ravens and score drawn on it. On line 68, inside click event listener, instead of scanning my main game canvas for pixel data, I will scan just collision canvas instead. Now when I click, it will ignore the black ravens and ImageData object will give me red, green, blue and alpha value of rectangle I clicked on. I will compare it with red, green, blue value inside random colors property on each raven to know which one was clicked on, and then I will set its marked for deletion property to true. There are many techniques you can use to compare two array-like objects against each other. Let's just keep it simple. When I click on one of these rectangles, I can see the values are inside this ImageData object on a property called data. Data is an array with red, green, blue and alpha value of pixel we clicked on. I create a variable to get hold of this array. DetectPixelColor.data, which refers to this uint8 clamped array with 4 elements. There is also a way to check for collision detection between two objects based on opacity alpha value like this, but today we will do collision between point and shape, between mouse and ravens. I will ignore alpha value from now on and I will just focus on these 3 values, red, green, blue. So this PC pixel color variable holds this data array with 4 elements. I take my ravens array and I call for each on it. For each raven object in the array, I will check if its random colors property from line 36, if the first element in the array, index 0, is the same value as pixel we clicked on. At the same time, we also need the second and the third element to match. If random colors array on my raven matches exactly red, green and blue values on pixel we clicked on, we know we have a collision. Index 0 is red, index 1 is green, index 2 is blue. We are comparing the two. If they match, we have collision, so I will take that raven object and set its marked for deletion property to true, and I will increase score variable by 1. Awesome, it works. I can click on ravens and they disappear and increase my score. I can set opacity on collision canvas to 0, and I can enable rainbow background on body element. Collision detection still works correctly. Well done if you followed this far, you are doing great. What should we do next? How about we add explosion animation and sound effect whenever we click on a raven? I will just repeat the same pattern we did for raven class. I create an array called explosions. It will hold all active animated explosion objects. I will create a class to create a blueprint for these objects. Its constructor will expect 3 arguments, x, y and size, because position and size will come from the outside and will depend on the raven we clicked on. This.image will be new image. This.image src will be boom png. You can download the sprite sheet for free in the video description. Sprite width will be 200 pixels. Sprite height 179 pixels. This.size will be size we passed as an argument on line 61. Same for this.x and this.y. These values come from the outside. This.frame, active frame will start from 0. This.sound will be new audio like this. This.sound src, source, and here as a source you can add any sound you like. For example, I will go to opengameart.org website. I click browse, sound effects, and I will search for Magic SFX, special effects. I will choose this pack of 4 sounds. I download it and I will use the one called Ice Blast. I will rename that file as a boom.wav and I will add it to my project folder. You can choose a different sound if you want. You can also have multiple sounds and play a random one here, it's up to you. In update method, same as we did before, I will use delta time to time my animation. We will have one variable to accumulate delta time values called, for example, time since last frame. It will start at 0. Then we need a second variable to define limit when the next frame triggers. I call it, for example, frame interval, and I set it to 200 milliseconds. I pass delta time as argument to update method. It will be coming directly from animation loop. I will show you in a minute. This .time since last frame will be slowly increasing by the amount of delta time. If time since last frame is more than frame interval, 200 milliseconds, I increase this .frame from line 69 by 1. I also want to play the sound when we are on frame 0, when the explosion first appears. There are better ways to do that, but for today I will simply check if active frame of this explosion is 0, and I take this sound from line 70 and I call built-in play method on it. Explosions will also need draw method, which will draw the actual sprite sheet animation. We will pass the draw image 9 arguments, same as we did with ravens. Image we want to draw, this .image from line 62, 4 values for area to crop out, single frame, so source X is this .frame times this .sprite width. Source Y will be 0 because we only have one row of sprites. Source width will be sprite width from line 64, and the source height will be sprite height from line 65. So now we told JavaScript what area we want to crop out. Now we need to give it X, Y width and height, where to place it on destination canvas, so this .x, this .y, and this .size for width and this .size for height. As this .frame variable increases here on line 79, because of this source X property, here we will show frames 0, 1, 2, 3 and 4. Now, where do we trigger this code to create and animate new explosion? The best place would be here, I think. This if statement detects collision by color, so when collision is detected, I take explosions array from line 59 and I push new explosion in there. This will trigger explosion class constructor on line 61. I can see it expects value for X and Y coordinates and size, because I want explosion to depend on the size of the raven we clicked. So here we are cycling through ravens array, referring to individual ravens as object. I want to pass X, Y and width of that raven as X, Y and size arguments here. Okay, that should work. I can test it by console login explosions array from line 59. I can see as I click and hit ravens, explosions are being added. Perfect. I made sure my explosion class has update and draw method, same as my raven class. That's why here on line 123 I can simply just use spread operator and expand the entire explosions array into this array I'm creating on the fly, so that I can call update on all ravens and all explosions at the same time, like this. I do the same thing for draw method on line 124. I like this syntax, it looks clean. Down here I will also remove all explosion objects from the array using built-in array filter method. I need to create a property called marked for deletion on my explosion class for this to work. As you can see, I'm repeating the same pattern we used for ravens. I hope that using the same structure like this helps you to understand and navigate in the code a bit better. Initially I set it to false. In update method I write an if statement. If this .frame from line 69 is more than 5, which means after all the frames of sprite sheet have been displayed one by one and explosion animation is complete, I set marked for deletion from line 74 to true. When I click on ravens, sound plays and explosion sprites are animated. We are making great progress, we just need to polish some details here. If I change frame interval on line 73 to 500, you can see it only affects the first frame. The rest of animation is playing really fast. Oh, it is because I need to reset time since last frame back to 0 every time, so it can count towards the next frame interval over and over to serve next frames. .500 milliseconds is too slow. Let's try 200. I want to align explosion animation better over the Raven sprites. Let's move it a bit upwards by adjusting destination y argument in drawImage method. I will make it relative to size, this.y minus this.size. This.size divided by 4. Yeah, I think this is aligned well now. Let's create game over condition. On line 11, I create a global variable called game over and I set it to false initially. Inside update method on Raven class, I create an if statement. If any Raven manages to get all the way across the screen and behind the left edge of game area, game will end. If this.x is less than 0 minus this.width, set game over from line 11 to true. And inside animation loop on line 132, I only want to run request animation frame and serve the next frame of our game as long as game over is not true, exclamation mark here. When Raven gets all the way across screen, game over will be set to true and game will stop, like this. I also want to display game over message, same as we did a draw score. I will create a function called draw game over. Fill style will be black. Fill text will be, for example, game over, your score is. Plus, I concatenate score variable. I want it in the middle of the screen, so x coordinate will be canvas width divided by 2, and y coordinate will be canvas height divided by 2. Now I need to call my draw game over function here in animate. If game over is false, keep serving the next frame. Else, call draw game over method to display message and final score. It's not centered. It's because these coordinates on line 101 mark top left corner and the text goes towards right and bottom from that point, same as when you are drawing rectangle or image on canvas. With text, it's easy to center by setting text align property to center like this. Yes, that worked. Same as I did with score, I want to give it shadow. I will use this trick where I draw the same text twice with different fill color and I offset it by 5 pixels. Nice. Let's change direction of background gradient, maybe 45 degrees, 125 degrees. Let's do a little bit of experimenting now and also to solidify what we learned today. I will use the same code pattern we used for ravens and explosions to add particle effects to our game. I will go a bit faster now, this part is just for fun. Feel free to run your own coding experiments. I create an array that will hold all my particle objects. I create particle class, constructor will expect x, y, size and color. These will be coming from outside the class and will depend on what raven is leaving this trail and creating these particles. It will be shooting from their tails. As usual, we will create properties for this.x and this.y. This.radius, since particles will be drawn as circles, it will be a random number tied to size of a raven. Let's try this formula and see what it looks like. Particles will be growing in size, so we need max radius to know when to remove them and also at which point they reach maximum opacity. It will be a random number between 35 and 55, for example. Marked for deletion, as usual, will be false at first. Horizontal speed x will be a random number between 0.5 and 1.5 because I want the particles to slowly drift to the right. This.color will be passed from the outside. Update method will move particles to the right horizontally. It will increase radius by 0.2 per frame and it will check if this.radius is more than max radius. If it is, it will set marked for deletion to true. Draw method will just draw a simple circle. Begin path to start the drawing. Fill style will be this.color from line 101. Arc method to draw a circle. I pass it x, y, radius, start angle and end angle like this. And we fill circular path with color. We have a class that will serve as a blueprint to create particles. I want them to follow ravens as they fly to create trails behind them. To do that, I go up inside update method on Raven class. Every time we serve next sprite sheet frame, at the same interval we are going to take particles array we just created and we will push new particle inside. My particle class constructor expects 4 values to come from the outside: x, y, size and color. So I pass it x and y of this raven, width of the raven as size argument, and this .color we use for collision detection rectangles will also be color of particle trail for that particular raven. You can see here on line 95, constructor wants these 4 properties to come from the outside so that it knows where on canvas to draw the particles, how large and what color. I can see I forgot to declare this .size here, like this. It will come from here and it will be used here to make radius of particle circles relative to the size of raven. Smaller ones should have smaller trails. So we have particle class. Here on line 52 we are creating a new particle object and pushing it into particles array. Inside animate I use spread operator again to expand contents of particles array here so that their update method gets called. And I also expanded here for draw method. I also need to make sure old particles with marked for deletion properties set to true get filtered out from particles array. Nice, we are drawing particle trails. You can see they come from the top left corner of raven hitbox. I will adjust that position a bit here inside particle class constructor. First I need to move this .size up so that its value is available for all properties coming after it. This .x will be x passed as argument on line 95 plus this .size from line 96 divided by 2 to center it horizontally. Yes, this .y will be y plus this .size divided by 2. No, that's too low. This .size divided by 3, much better. I want particles to be drawn behind ravens. We are drawing everything on a single canvas element, so how things are layered depends on the order at which JavaScript cycles through these objects and calls their draw methods for every frame. I will change the order here to draw particles first, and then ravens and explosions will be drawn over them, like this. Awesome, we have a working code. Let's clean it up. In update method on particle class, I want radius to grow faster. 0.5, 0.8, 0.5 is fine. Drawing trail on every single raven can be performance expensive. I want a property that will allow me to randomize it and allow me to set what percentage of ravens will have particle trails. On my raven class, I create a property called this.hasTrail. I want this property to be true for a certain amount of ravens and false for the rest. As Marcus pointed out in my generative art tutorial, any conditional expression results in a Boolean value, so instead of doing if-else statement here, I can simply just roll dice with math.random. Math.random, called like this, will return a random value between 0 and 1. So I call it and I check if that random value is more than 0.5, and that's it. It should be true roughly for 50% of ravens. This conditional expression results in a Boolean value true or false, depending on if math.random rolls a random number that's higher or lower than 0.5. I really like this syntax, very simple and clean. Inside update method on raven class, I will only create new particles if this.hasTrail is true. Like this. Now only half of my ravens will have trails. I also want particles to animate from fully visible to transparent. Inside draw method on particle class, I set global alpha property on my canvas to be 1, which is maximum, fully visible, minus the current size of the particle divided by max size. As the particle's radius grows, eventually radius will be the same size as max radius. So let's say max radius is 30 pixels. At that point where the current radius is the same size as max radius, we will have 30 divided by 30 here, which is 1, and 1 minus 1 is 0. Particle is slowly growing more and more transparent, and at the point when it reaches maximum radius, it will be at 0 global alpha. This formula might be a bit difficult to completely understand if it's the first time you see it, but it's very useful. We will talk about it again in some other video. As you can see, global alpha is spilling over and affecting my ravens as well. That's an easy fix. If you want to change some global canvas properties such as fill style, global alpha, rotate, translate and so on, and you want those properties to affect only a single element you draw and not the others, you can just wrap that drawing code between built-in save and restore methods. Save will create a snapshot of current canvas global settings, and then we change global alpha here, which will affect just this one particular particle, and then I call restore to revert canvas settings back to what they were at this point. Save and restore are especially useful for rotating elements on canvas, but you can also use them for other things like this. My particles are blinking before they disappear. It is because JavaScript first runs over the entire array before it filters the particles that are too large out. And my global alpha formula works only in a specific range between 0 and max radius. Some particles get outside that range and are drawn fully opaque for a second before they get filtered out. To fix it is simple. I just trigger mark for deletion a little bit sooner. For example, by saying max radius -5 in my check on line 111. Let's make the trail nicer. I will add 5 particles every time instead of adding just 1. On line 54, I create a for loop like this, and I put this code inside. If I make radius grow slower, trail will be longer because it will take particles more time to reach max radius. Be a bit careful here not to have too many active particles on screen at once, because at some point it will start affecting performance and frame rate. I can also randomize the initial x and y coordinates a little. For example, I can add a random number between -25 and +25. I think it looks a bit more interesting like this. I can also add more enemy types. For example, I can add fast flying bats that will be worth extra score points. Maybe I want ravens with trails to be worth more score but also have more lives. There are many things we can do here. If you are still feeling creative, check out some of my playlists. I have creative coding for beginners, game development playlists, and advanced animation effects. Everything with just HTML, CSS, and plain vanilla JavaScript. No frameworks and no libraries. Check out some recommended courses in the video description. I'll see you there.